Okay, let's take a look at our lesson for today. It's on measurement of rotation. We have several different vocabulary words that we're going to be working with. I know maybe you don't think about math as having vocabulary, but maybe you think English does. Math does too. Because if you don't understand what the words are saying, you are not going to know what to do, right? So it's really important for us to understand what the word is. Our first vocabulary word is standard position. We want an angle in standard position. So let's focus on that for just a moment. That's our first vocab word. And for it to be in standard position, it has to meet these criteria. Okay, it has to, its initial side has to be along the positive x-axis. And let's talk about that for just a moment. You know, in geometry, you would have angles like, you know, all over the place. Maybe that's 95 degrees. I don't know. You know, just kind of different angles, right? Those are angles, and that would have been fine. Maybe you would have had arrows on it in geometry. Those aren't in standard position. Okay, those aren't in standard. To be in standard position, it has to be on a coordinate plane. So what I'm going to do is I'm going to plot this first one. I'm going to put it in standard position as I talk to you about it. So the initial side being along the positive x-axis, what does that mean? All right, what that means is it starts here, you know, it's at the origin. It says the vertex has to be at the origin. So this is my initial side. Okay, that's where our angles start when they are in standard position. The terminal side is the other side of the angle, the terminal side. And the terminal side can be in any quadrant or quadrantal. Now, quadrantal may be another vocabulary word that you're not familiar with. What does that mean? A quadrantal, that's the x and y axes, those pieces of the x and y axes. Those are called quadrantals. So yes, it is possible for us to have a 90-degree angle, right? I would put the terminal side on the quadrantal here at 90 degrees. So that's possible. All right, so direction. Counterclockwise is positive. So if I rotate this way, it's positive, which I think you learned last year, right? I think that's normal. And then if I go clockwise, again, starting at the x-axis, this way is negative. Okay, so those are the things that help us determine whether we're in standard position. Now, let's put this angle in standard position. I already have its initial side here. We need its terminal side. Now it's 200 degrees. We know it's positive, so we're going to do a positive rotation. As I move this way, that takes me to 180 degrees, right? We know that, 180. 200 is more than that, right? So 200 is going to be a little bit more than that, so maybe right over here. Now, am I looking for you to draw a perfect 200-degree angle? No. I just need the terminal side to be in the proper quadrant. You know, if you get a little carried away, that's okay. Just be sure it's in the proper quadrant. So this would be our 200. We know this is 270. So what would I do? I would draw this part right here. Notice how I'm showing direction. It's positive, so I'm showing that it's going this way. I'm showing the direction, and then I label it. So when I ask you to sketch the angle in standard position, this is exactly what I'm looking for. This is it. Basically, you sketch it, you know, show the way it's being rotated, and you put the 200 degrees on it, and you're done. Yes.
So do we have to draw the arrows?
Yes. Yeah, I need you to draw the arrows. I need it to look just like this because I need you to show me that you know. Oh, no. You can if you want to, but you don't have to. All right, so let's say that this was 360 plus 200. I just want to show you what that would look like. So I'm doing a coterminal angle, aren't I? I'm doing 360, so what is that? 560. Okay, so say we're doing 560. All right, I just want to show you what that would look like. Okay, we would be going one time all the way around, and then we would come to that spot. This would be 560 degrees. Okay? So that's what this angle would look like. And this full rotation tells me that I have one full rotation. Okay, so it might be kind of fun to have you draw one with 10 full rotations, but I'm not going to. I mean, that would be cool, right? This big old spiral. But no, we're not going to do that. But just know, I mean, that's what you need to do. If there's an extra rotation on it, you need to show that. Okay? We okay? All right, so let's do one more on standard position, and then we'll move to our next vocabulary word. We have negative pi over 5. Yes, it's in radians. I love radians. All right, negative means that we're going backwards, right? Our initial side is still right here. It's still right there on the x-axis. But now we're rotating backwards. If this was positive pi over 5, I'd be in the first quadrant, right? Because this is pi over 2. We know pi over, 1/5 is smaller than 1/2, right? It would be in here. But it's negative pi over 5. Means I have to rotate a completely different direction. I've got to go backwards. So that's going to put it in here, right? That's where our negative pi over 5 is going to be. I'm going to show this rotation, and then I'm going to label my angle as negative pi over 5. And that's all there is to standard position. Questions on that? So when you see a question that says, sketch the following angle in standard position, you know exactly what's expected. Okay? Let's go to our second vocabulary word for today, which is coterminal angles. You're going to be asked to find coterminal angles. What does that mean? I've been alluding to that for some time. What does that mean? It means they have the same initial side and the same terminal side, but they may have lots of rotations on it, right? So I could actually go this way, and whatever that would be, 360 minus that, what, negative 160? Okay, you'll discover, yes, I can do calculus beautifully in my head. Can I do numbers in my head? No. So if I make an arithmetic mistake, help me. So I'm going backwards this way, right? This angle, negative 160, is coterminal with 200, and that they both are coterminal with 560. Right? So how do we get coterminal angles? We're either going to add 360 or subtract 360 if we're in degrees. If we're in radians, we would add 2 pi or subtract 2 pi. I mean, that's all there is to it. And there's an infinite number of coterminal angles. Here's a typical problem that you might be faced with. Find a positive and negative coterminal angle for each of the following. Okay, not bad. So what do? We take the 135 and we add 360 to it, which gives us 495. So that's our positive coterminal angle, so 495 degrees. Then our negative coterminal angle, what do? We take the 135 and we subtract 360, and that gives us negative 225. So negative 225 is our negative coterminal angle. Okay, how's that? Not bad, right? Okay, so radians. I love radians. Okay, so radians, finding the coterminal angles may be just a little bit more difficult because we're dealing with a fraction. Okay, we just need to know fractions are our friend, right? They're nothing to be afraid of. So I know I have to add 2 pi to this, but 2 pi in terms of fourths isn't 2 pi, right? That's 8 pi over 4. Right? I need to make it the same denominator. We're adding and subtracting fractions. So I'm going to add, so I have 3 pi over 4. I'm going to add 8 pi over 4. That's going to give me my positive coterminal angle, which is 11 pi over 4. Okay, the second thing that I'm going to do is I'm going to subtract 8 pi over 4. Right, so we have 3 pi over 4 minus 8 pi over 4. And that gives us our negative coterminal angle, which is negative 5 pi over 4. Okay, how are we? Not bad, right? So we got coterminal down, we got those vocabulary words, we have standard position. One more concept on the second slide that we need to talk about. So let's go to the second slide. Okay, the third vocabulary word for us today is reference angle. Reference angle. What is a reference angle? Okay, so here we have some steps to find the reference angle. If the angle that we're given is larger than 360 degrees or 2 pi, or smaller than negative 2 pi, negative 360, We really need to find the coterminal angle between 0 and 360 or 0 and 2 pi. We need to pull the extra rotations off. Okay, we need to pull them all off so that we can figure out which quadrant we are in. So that's important. We need to know the quadrant that we're in, because depending on what quadrant we terminate in depends on how we find our reference angle. First of all, the reference angle must be acute, or in rare instances a right angle, but acute. And it's between the x-axis and the terminal side. One of the most common mistakes that students make is to try to make the angle between the y-axis and the terminal side. That is not a reference angle. That may be a fun angle, but it's not a reference angle. Okay, so a reference angle, and there's basically a diagram down here of the 4 options. You only have 4 possibilities. If your terminal side falls in the first quadrant, then your reference angle is just this part right here. Just see, between, this is the terminal side, this is the x-axis. My angle's between the terminal side and the x-axis. Now, something that I have not written up here that you need to write up here is that all reference angles must be positive. I didn't put it up here, but it is a requirement. So write that down. Write on your paper. All reference angles must be positive. Okay. So if we are in quadrant 2, if the terminal side is in quadrant 2, then our reference angle would be right here. Notice they're using the Greek letter alpha. That is the typical Greek letter that we use to represent reference angles, is alpha. That's just the norm. So here's my reference angle. Notice it's between the terminal side and the x-axis. And how would I find that angle measure? Well, I could use logic, right? We're very intelligent, very logical in here. We could memorize the formula, or we could use logic. What could you do? You could take the 180 and then take that out, and you'd get that. I mean, that's kind of what we would do. If we are in the third quadrant, this is where our reference angle would be. Again, notice it's between the x-axis and the terminal side. Fourth quadrant, again, no surprise to us, between the x-axis and the terminal side. Okay, so that's where our reference angles are located, and they always have a positive direction on them. So we have a couple of examples to do, and then we will start on our daily work. So let's look at these couple of examples. We're asked to find the reference angles, and I think we can tell with number 5 that this has some extra rotations on it. Right, it has some extra. I need to pull the extra rotations off. So I know, let's see, we have 720 degrees. We have 3 extra rotations, so we're going to pull those off. So we're going to take the 1066 and we're going to take off the 720, and that leaves us with 346. So our angle that we pulled off the rotations, it's 346 degrees 9 minutes. That's the angle that we're looking at. So let's just, I really like to draw things. I want to get a picture of what's going on. So let's see. So 346, we know this is positive, so we're going to be rotating this way. Past 180, past 270, we know it's going to be in the fourth quadrant, right? Somewhere down here. So that's where our angle would be. So this angle is our reference angle. Reference angle, we're using the Greek letter alpha. All right, so how in the world are we going to find that? So we could, memorize this formula, or we could just really think about it. What do? We know this whole distance around is 360, right? If I have the whole distance around is 360 and I take off the 346, won't I be left with my reference angle? Right, that makes sense? So that's what we're going to do. Excuse me. So maybe we remember how to add and subtract with degrees, minutes, seconds. Maybe we don't. I got some very puzzled looks earlier today, so maybe some of us don't. So I'm going to kind of go through that. So we really need to do 360 degrees minus this. Right, well 360 is all in degrees. There are no minutes pulled out. I need minutes. How do I do that? I borrow. It's a really fun game of borrowing. Right, because 1 degree is equivalent to 60 minutes. So I can write, 360 degrees is the same quantity as 359 degrees and 60 minutes. Right, these are equivalent. Is everybody okay with that? So what I do, I borrowed a degree and I turned it into minutes. Now you will come across a time, most definitely, when you have to use seconds. Okay, just in case this is new for us, right? I need to kind of go through that. What if I needed seconds? What would I do? I would borrow again. I would borrow a minute from here. That's what I would do. If I borrow a minute from here, that pulls that down to 59, doesn't it? I'm just going to show you. So 359 degrees, 59 minutes, and when I borrow 1 minute, that turns into 60 seconds, right? So I just need us to understand that these three quantities are all equivalent. They have the same value. It just depends on what form we want it in so that we can deal with whatever we have. Okay, so I'm going to use this form because I don't have any seconds. I just have minutes. So we're going to take 359 degrees, 60 minutes, minus 346 degrees, 9 minutes. So we do 60 minus 9 is 51 minutes, and then 359 minus 346 is 13. So this is our reference angle. Our reference angle is 13 degrees, 51 minutes. That's the value of that angle right there. Okay, how are we? We okay with degrees, minutes, seconds? All right, last example, then we go to our daily work. We have one in radians that we need to work with. Okay, so we have negative 43 pi over 3 radians. There's more than one rotation on there. We're going to have to pull that off. Let's think about this for a second in fraction form. So we know we pull off 2 pi. 2 pi is a full rotation, but we need it to be, a denominator of 3. So we're looking at 6 pi over 3, right? We want to pull off multiples of 6 pi over 3. Does everybody have this part that they need? I need to erase that. Okay. All right, so we need to pull off, we're looking at 6 pi over 3 because we need the common denominator, right? We need to think about multiples of 6 that go into 43, right? So we're looking at 42 pi over 3, right? We all agree that's the highest multiple of 6 that will come out of the 43, right? So we're going to pull that off, and what are we left with? This is negative, right? I'm just talking about the rotation. I'm just pulling off rotations. I haven't gotten to the, I'm just getting ready to get to the negative. So we pulled off the rotations and we're left with negative pi over 3. Okay, that's what we're left with. Now, we need to know what quadrant that's in. Is that our reference angle? No. Right? We were talking, reference angles cannot be negative. That is not a reference angle. But it does tell us what quadrant we're in. Right? So if it were positive pi over 3, I would be up here. But it's negative pi over 3, so that means I'm down here, right? That's where I am. Now, my reference angle is going to have a positive rotation. That's going to be my alpha, a positive rotation. And that angle measure, that space right there, is pi over 3. Right? So my alpha is pi over 3. Okay, how is that? The very last thing that I want to talk about is the Greek letters up here, just as a kind of a fun thing. Do you have to memorize all the Greek letters? No, that's not why I'm talking to you about them. It's just that these are the most commonly used Greek letters for angle measures. Notice how we used alpha for our reference angle. You're probably very familiar with theta, right? That's like a popular one. Theta is very common. We have alpha, beta, and gamma we use in multivariable calculus quite a bit. And omega we'll be using in a couple of days. We usually use that to talk about angular velocity. And then this little guy right here, I so want to say phi, but it's not. It's phi. The way you pronounce it is phi. It seems much cooler as phi, though, doesn't it? At any rate, I don't get to pick. So these are just the most commonly angle measures. Okay? All right. How are we on this lesson?